Hey all, in this video we are going to see about a new structural design pattern which is called proxy design pattern. So we are going to see about proxy design pattern which is a structural design pattern. So like why we use this proxy design pattern first. So the proxy design pattern is mainly used to keep a proxy object that is mainly used to control the access to the real object. So we have a proxy object, and that proxy object is used to access the real object. So that is called the proxy object. So you can think of use cases like where the object shouldn't be accessed directly due to security concerns, or let's say we have to do some logging or caching before calling the real object itself. So those things can be done inside the proxy object itself before calling the real object. Let's think of a use case where the object creation itself is expensive, right? The real object creation itself is expensive. So in that case, we have to define a logic in the proxy object stating that if the real object is not there, then only create it. Don't create it every time. So that's how we can do memory management also by using this proxy design pattern. Let's see how we have to implement this. So let's say we have a subject that is actually an interface. So interface, there we have to define methods like it has to say what to do. So the method will say what to do, but it doesn't say how to do. So this interface will be implemented by both the objects, right? So it will be the real subject also. It will be the proxy object also. So both classes will implement this common method in interface. So let's say this interface has a method called request, let's say. So this real subject will try to override that method and try to implement its own implementation under this real subject. So the object of the real subject gets created only inside the proxy object. So inside the proxy class, we are trying to create the real object creation only when it is needed. So the expensive memory management can be avoided. So if the object is already created, then we don't need to create it. If the object is null, which means the real object is null, then only we have to create it. So in driver class, again we have a creation of proxy object, and in proxy object we have a creation of real object. So this is how the proxy design pattern works. Let's see how to implement this in Java. So I have a folder called proxy, which I have already created. Let's try to create a new interface called service. So this service is an interface. I'm trying to add some methods inside it. Public void, let's say request, and I will just declare it without defining it because it's an interface and it's an abstract method which doesn't have any implementation. So let me create a new class which is the real object class. So I will name that as real service, and that real service should implement our interface. Okay, let's implement all the methods in that interface. So I have overridden it, and I'm just trying to print something here. Logging from real service, just to make sure this instance is getting triggered. So that's why I have just given a printout statement here. So that's it on this real service. Then we have to create a proxy service now. proxy service. Then again, the proxy service will implement the same interface, implement service. Let's implement the methods, which is same as this thing. Here, I will print like logging from proxy service. Okay, fine. Now we have to create a real object here. So how can we create a real object? So let's create the instance of the real service here. I will keep the access modifier as private because it shouldn't be accessed from outside. Real service, I just create the real service instance here. Instance is created, but I have to create an object for that instance. So I'm just checking if real service equal to null, which means if the real service object is not there, then only I'm trying to create a new object. So that's it. So this new real service will try to invoke the real service itself, which has this request method, and it will print from logging from real service. It will print. So again, let's print here logging start from proxy service. This I can print as logging end from proxy service. So you can think like this logging is being used at proxy layer itself, and this check is used for memory management. So if real service is equal to null, then only I am creating a new real service object. So this is how the memory management is being done in proxy design pattern, and this proxy is used to control the access of the real service object itself. That's why we say that access proxy, which has the real control of the real object. So let's try to create a driver class for it. So I will define that as main class. Let's add public static void main, and I will try to create a object for it. Service is equal to new proxy service. I have to create, and service dot request. So if I try to execute this, it will try to execute the proxy service first, and from proxy service, it will execute the real service. That's how the proxy design pattern works. Let's see the output. Yeah, you can see logging start from proxy service, logging end from proxy service. Okay, but we are not seeing that. Okay, because we haven't called that, right? We have just created an object for it, but we never called that request method. Okay, now let's try to execute the driver method again. Yeah, logging start from proxy service, logging from real service, logging in from real service, proxy service. So that's it. So this is how proxy design pattern works, and it's mainly used for memory management, and it acts like a security layer, it acts like a logging layer, it acts like a cache layer. So whatever use cases you have to implement, you can use this proxy design pattern while implementing in your code. So yeah, that's it, guys.